Hey there, and welcome back to another episode of Decker Lessons. My name is Michael, and this is Decker, a charming and surprisingly powerful tool for making things on a computer. As it says here, anyone, including you, can extend Decker by creating reusable contraptions. And so in this lesson, we're going to look at this grid selector contraption, which is all about drawing clickable grids. You can see here we have the tic-tac-toe game that we made. So laying something out in a grid only takes a few lines of code. It's a little bit of arithmetic, but whenever you find yourself using the same logic repeatedly, it's worth taking the time to bundle it into a contraption, which you can then copy and paste into another deck. If you want to follow along with this, there's a link in the description to a web page where you can run this exact deck in your browser, and you can copy by going to Tool Widgets or clicking this button if you're in Toolbars open. You can copy any of the widgets with Edit, Copy Widgets, and then by opening a new deck, you can simply paste that in, Edit, Paste Widgets, and when you go back into the Interact view, you'll see it's right there. You'll see that when you go to File, Prototypes, this grid selector has now been added to this new blank deck. And if you copy the color selector, you'll get a color selector. These are the brushes that you can use to draw in Decker and so on. All right, so let's get started. Okay, so usually my first step when I'm trying to think through how to write something in code is to do it by hand, or at least imagine doing it by hand, and try and verbalize what it is I'm actually doing. So if you have any experience with Decker at all, my challenge to you is to just try and draw a grid yourself. I encourage you to pause the video for a second and just think about this. What is it you actually need to draw a grid? So when I think about this, these 4 parameters are basically the main things we need to specify what the grid looks like. We're going to draw some lines, and we need to know how far apart they are, the width and height of each cell. And then we need to know how many cells to draw, so the width and height of the grid itself. My challenge to you is to actually sit down and draw a grid and figure out what is it you would do to make that happen. So like there, I drew a square, and then I drew some lines going down and some lines across. Not terribly great grid, but there you go. And then once you verbalize what you want your algorithm to be, how do you put that into words that the computer can understand? This code here does not draw a grid, but it gives you all of the basic things that you might want to use in an algorithm. So what's happening here is that first we're grabbing the value of these widgets up here and storing them in variables. C is the name of the canvas, and it's going to be that way throughout this video. So we're asking to clear the canvas, set it to pattern 1, which is this black color. And then these are just some lines that might help. The width and height is the calculation. The width of the whole thing is the grid width times the cell width. The height is the grid height times the cell height. This is the syntax you can use to draw a box. So you have the start upper left coordinate and then the width and height. When you call box, it draws the outline. When you call rect, it fills it in. The each keyword allows you to loop through a list. And in this case, we're taking the range 5, which is just the numbers 0, 1, 2, 3, 4, and we're multiplying it times the width to get this spacing up here, the cell width. And then we're drawing a line. So this is how you draw a line. You just pass in each pair of coordinates that you want to visit in your line. So in this particular example, the grid width is a single number which is being added to this pair of x comma 0, which is how we are offset from both the top and the left here, incrementing by the cell width every time. And then C size is the bottom right coordinate of the grid. So the point of this is to just give you the vocabulary to draw these things. And then for a little bit more help on drawing, there's a quick reference to the canvas widget with some documentation and some example code here. I'm not going to go into this. This is for you to explore on your own. My challenge to you, if you're following along at home, is to pause the video here and try to write a little program to draw this for yourself. And when you're ready, we'll click next. Okay, so this is how I would do it. As it says how I draw by hand is to draw the lines individually. There's one more than the number of rows and one more vertical line than the number of columns. And so the way to model that is to first do a loop through the y coordinates, drawing from top to bottom, and then the x coordinates, drawing from left to right, by calling the line inside of a loop. And so as we run this, you can see I put a little sleep in here, and that's going to wait for 2 frames between each step of the animation. So when we click run, there you go. And hopefully, if we change some of these parameters, we'll get a different grid. Okay, so not too hard, basic arithmetic. If you don't know, you can hit Control and L to open this listener down here. And if you want to see what any of this does, you can say range, say 5. There you go. in order to find out what GH is, you have to actually define it. So this does not get run. If you make it part of the script on the page, it'll run. But to do it in the listener, you have to hit Shift Enter, and there we go. And then we can say range GH or whatever. And so we can see what's happening there. So if you want to explore that, you can do that there, or you can just hit the run button and see what happens. Okay, so that's drawing with lines, and let's move on. Okay, drawing with rectangles. So this is another algorithm, and I'm just going to go ahead and run it. And so now we're drawing one little cell at a time. And that is done in a single loop with this cross keyword. So cross, just like range, when you say 3 cross 2, what you're actually going to get is the cross product of those ranges. You can actually do this with any arbitrary list. You can say ABC cross 1, 2, 3, and you get the cross product of those lists. So this is a pretty helpful thing if you want to visit every combination of a system, which is what we're doing when you draw a grid. So now we're going to multiply that. In order to scale those points, we're going to multiply them by the cell size, which is just the column width and the column height. As it says, this is a little bit slower because we're visiting width times height instead of just looping through width and looping through height. But it winds up being fast enough, especially when we're doing the custom drawing, we're going to use this technique quite a bit. All right, so why would we do that? Before we move to the next card, just take a little snapshot in your mind of what this says. Each XY in the cross product. And when we click next, you'll see it's changed to each XY high in the cross product. And when you run it, you can see that this I gives you a lot of flexibility. So this line right here draws these background squares, which are these colors plus all the black and white patterns. And we're using I to do that. We have that number. We're able to basically pull it out of a selection of 48 different things. So then this draws the boxes around it. This draws the little white boxes. And then we can use the text method to center the number I within that smaller box. So just one small thing, you'll see when you actually use the grid selector component that you get a script very much like this as your default template. And you might be a little surprised by this list word here, because what list does is it takes this thing, which already is a list, and wraps it in another list. List 1, 2 is a list. And then when we write list 1, 2, we put that inside of another list. And this is going to be provided for you so you don't forget it. But if you remove it, you'll see that the grid is corrupted. What's happening here is that when Lil sees a list of points on the left and then a list of 2 numbers on the right, it sees they're not the same shape, and it's going to prioritize the shape on the left. And so it causes the thing on the right to conform to that shape. So what's happening is that we're getting the width, the height, the width, the height, the width, the height over and over again. And that's why you get 2 separate little offsets when you do this. They're basically scaling by a single number. Whereas when we put the word list in here, then the entire list is treated as a single unit, and that gets copied over and over again. It can be a little surprising. And in fact, if we put this in parentheses and move it over to the left, you'll see that it only draws 1 square. And if you remove the list, now it draws 2, because you've got 2 things on the left. With list, you have 1 thing on the left. So what that means is that the multiplication sign, which is normally what they call commutative, meaning that x times y is the same as y times x, in normal arithmetic, that's not the case when you're dealing with these multidimensional arrays in Lil. And that's just something to be aware of in the back of your mind. But the template you get with this contraption is set up so that you don't really have to think about it. Okay, next. Right, so at this point, we want to start clicking on the grid. I just want to show you something that Decker provides that we're not actually going to take advantage of here, but it's just nice to know if you want to do something like this at a much simpler scale. And that is that if you take a canvas and you go to the widget tool and you click on it, you will see it has a scale operation. By changing that number, you can scale the size of the pixels. The canvas actually will have both a size and what is called an L size, a logical size. If you change this scale, it'll change the size of the canvas. So if I change that from 9 to 4, you see it got much smaller. When I run this, it'll put it back to 9. It'll set it to a 16 by 16 grid, which is actually going to be 9 times 16 pixels, which is 144. So when we run this, it's going to fill up that 16 by 16 grid with some random pixels here. Yeah, so there we go with these colors. This is going to take this list of background colors, which are names in the global colors dictionary. It's going to make a new image with the logical size. It's going to set the pixels to a list, which is simply a copy of the number 3 taken 16 times 16 times, so 256 times. And then when we apply random to that list of the number 3, we get a bunch of random numbers that are either 0, 1, or 2. And then by using the same @ sign, we can use each one of those numbers as an index into the array of things into this array of colors. You have to define it in the listener, of course. So that is going to create a random pattern here. And you can see that each pixel is scaled up to what happens to be a 9 by 9 square. So when a canvas is scaled like this, you can see that if I click anywhere in this square, this is the click handler, you can see that there's a field here called F, and it is setting the text of that field to the position that it gets in the click handler, which it was 0, 0, even though I clicked in the bottom right-hand corner. So anywhere I click in that field is going to be 0, 0. And you can see I also set the pattern to colors red so you can draw on this. So simply by creating a scaled canvas and setting the pattern on it, you can create a little pixel editor. If all you want to do is draw squares, you might not even need the contraption we're making. But if you want to do fancy custom drawing for each square, or you don't want them to be square, then we should keep going. So onward. Okay. So you can see now that as I'm moving my mouse around, we have this little line of code here that is showing you the values that are being calculated on each frame as I move the mouse around. The pointer is a global interface, and on every animation frame, it shows you the coordinates of the mouse pointer. And of course, Decker is designed to also work on tablets and touch devices. And so in that case, you would get the last known position of your finger. And as it says, the way this works is that you can flag any widget as being animated by going into the widgets menu and checking this animated thing. And when that happens, it receives a view event on every frame. So on this view event, there's actually some complicated logic here that is basically running this code and then filling it in. Not very pretty, but it makes for a nice demo. So what's actually happening here is that we are taking this pointer position, we're assigning that to the value P0, so we can go line by line. And then we are subtracting the canvas's position from that. And so what that means is that as I move the mouse to right up around here, you will see that it gets closer and closer to 0, 0. Sometimes it's a little hard to get your mouse exactly on. And so if you're over the canvas, then the second value, P1, is going to be the coordinates within the canvas. And so that's obviously something we need if we want to detect a click at a particular grid coordinate. So this down here is just the thing that will draw a grid for us. So we want to be able to take these numbers here that are coming in from the pointer position, and we want to be able to turn them into these grid coordinates, which again is what the scale system did, but we could only draw a single pixel when we did that. So now we have the ability to draw like these text coordinates, for example, next. And this little black script is going to be the same on the next couple of slides. So you can just go ahead and run that if you're following along. Okay, on this page, we consolidated that into one line, and we're showing how to actually convert it to the numbers we want. So now if I put my mouse over, say, 0.5, you'll see that it says 0.5 over here, 0.4, 1.3, 2.2. And all we're doing is we're dividing this number P0 by the cell size. Cell size is defined by these two widgets. They're separate integers, and we want to combine them into a pair to get this 25, 20, or whatever it happens to be on that particular frame. This is just a handy syntax for doing that. So John Ernest, the creator of Decker, pointed this out on the Decker forum in response to my last video. So I thought I'd pass it along here. That you can take these two widgets, you make a list of them, and now this dot dot is basically syntactic sugar for this each loop here. So it's as if we were looping through and then doing x dot value. And of course, when you do an each loop, the last expression in the loop is added to a result array. And so the entire thing produces an array or list of values. And so this is simply a shorthand for extracting these two numbers out of these two widgets. And of course, the word value is just the name of the number that is held inside of a slider. So then we divide that. That's going to give us a number with a remainder after the decimal point. And so of course the floor of that rounds it down to the nearest integer. And so that is the calculation we need to take a mouse coordinate and turn it into a grid coordinate. Next. All right, so now maybe I should have drawn the numbers here. In fact, let's do that. This contraption down at the bottom is called the tutor widget. And you can go into the widgets menu, double click on it, and you can just change this. So if you want to change the code in here, if you mark it as unlocked, you'll be able to edit this. So we can just do that here. And so now instead of using the X and Y coordinates, we could just put I here. All right, so now we want to get these numbers is what I'm getting at. whereas previously on the previous card that said view, now it says click, and you see there's an extra parameter here called position, POS. And when we click on the squares, we're actually setting this value. So this is a click handler that is actually setting the value of the slider here called current. And the click actually tells you where you got clicked. So we get that mouse offset. So if we click up here, you can see it's 1.1 or whatever. And so we have to do our division to turn it into grid coordinates. And now the new stuff is this operation. All right, so what does this say? So remember that Lil evaluates from right to left. So what this is doing is we're taking 1 comma the grid width, so 1 comma 6, and we're multiplying it by xy, which is the grid position. So here we're getting 0, 0. Here on the number 6, we're getting 0, 1. And on the number 1, we're getting 1, 0. And we multiply that by the grid width. So now this becomes 6 comma 0. And so these are paired. So we want to multiply the x value times 1 and the y value times the width. And why do we do that? Because as you go across, as you increase in the x direction, a move 1 square to the right adds 1. And when you move from that square 1 square down, you add 6. And that is because you are adding an entire row, right? And so you need to know the width of the row. And so we want to scale the numbers that we get for the coordinates by this 1 comma 6. In other words, the x is scaled by 1, the y is scaled by the grid width. But now we want to add those together, right? When we scale it is 0 comma 6, and we want to add those together to get 6. And then here we have 1 comma 6, and we want to add those together to get 7. Here we have 1 comma 12, we want to add those together to get 13. And so that's what's going on with this calculation. Sum is a built-in that takes a list and just adds it up. Without that, we'd have to break the XY pair into individual components, and we say X plus Y, right? But this sum keyword, and there's also a prod for product, allows us to work on the entire array at once and basically keep the code very concise. So all along, we're able to keep X and Y together in this list XY, and that's the array programming style. Okay, so once we have this, we store the number IX, and then we just assign it to the value of this slider. Okay, so now that we can detect a click, we want to give some feedback to the user where that click happened. And that is what this code does. As we go through the loop, we just continuously compare the loop index to the current value, or where current value is stored in a slider widget. And if I is equal to that value, then we draw the square in blue. Otherwise, we draw it in cyan, or do whatever it is you want to do to mark the cursor. And then now this script below shows another way to do that without the loop index. If we want to go from this number 28 to this square on the fly, the way to do that is to reverse our arithmetic. And we want to take the index, the current value, modulo the grid width. So in other words, we want to divide by the width, and then the remainder is going to be the x coordinate, and the division without the remainder is going to be the y coordinate. So we round down because to fully divide, we need a whole row. And so if we're only part way across the row, we want to show up on this row and not the next row, right? So in other words, here we have a grid that's 8 across, and if we're on cell number 4, which is this one, we want to round down to row 0, not up to row 1, if that makes sense. Once we do that, we take the remainder, and then the division without the remainder, the integer division, gives us the grid coordinates, which we then scale, once again, by the cell size. What this code does is it's just going to draw 2 different boxes that are nested inside of each other. And so that just kind of gives you a nice cursor that no matter what your background is, you've got a white box, you've got a black box. One of those 2 is going to stand out against whatever your border is. I suppose if all of your cells were filled with nested black and white boxes, then that might not work so well. But otherwise, it is a pretty good default. Just one other small note, just the modulo sign might be reversed from what you're used to. Since Lil executes from right to left, it winds up being a lot more convenient to have this on the left sometimes. Because you might want to say this plus 5, and you want that whole expression modulo whatever's on the left over here. And so it works out better to have it on the left. You can make the same argument for division, but for whatever reason, array languages just tend to not do that. They tend to do this one and not this one. Okay, next. All right, so now, having done all that arithmetic, we now know everything we need to know to understand how the grid selector works internally. And so now we just have to use it. So to use the contraption, you're going to go to the tool menu and widgets, and you're going to click widget, new contraption. And because we have it installed in our deck, you can click on it and you can click create. and you'll get this default selector here. And when we go back to interact mode, you'll see that it just creates like a default empty grid with the cursor that you can drag around. And when we click on the properties of this, there's a lot of things you can configure in here. So of course we have the width and height of the cells and the grid itself, which we can change. So if we say make this 20, it'll be a little bit rectangular. And if we make the grid width until 16 or something like that, and then as soon as we click OK, it's going to redraw that, resize the widget for us, and you don't have to scale it. If you look back here, there's a margin here because the grid does not fill up this entire canvas. And you can also have the situation where the grid overflows the canvas. And so in either situation, you want to trim to size. And we do that automatically for you in this contraption. And of course, we just scale it to the grid width times the cell width and the grid height times the cell height. Okay, widget mode, click on this. Or you can also, in widget mode, double click on it to see the properties. The pattern allows us to change the color of the grid. So set it to something like 42 and you'll get one of these colors. Of course, on the one screen where I want to use the help, it's not there. So during the tutor widget, you can click on help and go here. And you can use this to figure out what the number is, which I find very helpful. So if I want to make those lines red, I can click on red and I see it's number 35. And then when I click here, 35. You can set up a lot of types on here, but there's no current way to say that the type of one of these parameters is a pattern. And so you don't have a dropdown like that. So you just have to know the numbers. Okay. Although you can do this, go to widget pattern. And then when you set this, you click on it. There you go. And you go back to interact mode. It sets the background color. Every widget has a pattern and a font and so on associated with it. And although I don't think I actually handled the font, I do set the background color. Some of the newer Deckers have a thing where you can click on the right here and it sets I guess you'd have to be on the widget here. But yeah, I guess it doesn't work for contraptions. But for many things, like you set a button to a particular color just by clicking on this now. John just did this. It looks like the flow is to click on it, click on the color you want. That does not send a view event. But then when you click on interact mode, it does send a view event. And so you get the new contraption. Okay. I guess the reason you wouldn't be able to do it from interact mode is because even though you've just clicked on it, there's no notion of focus. Decker doesn't have a concept of like the current widget, except in the case of buttons and fields. So this doesn't know that it's active per se. Okay. In any case, you can set the background color. And what else can we do? I'm going to skip data for a second. So we can choose whether to draw the cursor. We can choose whether or not to auto resize. You might want to leave some space on the end. And then you can choose whether to drag to draw. And so I guess I need to show the cursor to do that right now. So right now I can drag the cursor, just drag it around as if I'm drawing a picture. And I'll get a click event for every single one of these squares that I visit. Whereas if I turn off drag to draw, then I cannot drag like that. And then if I turn off the cursor entirely, then it just shows the grid. And likewise, if you set the grid pattern to the color 0, it will also not draw the grid. So if you wanted, you could just get a cursor, or you can just draw whatever you want on the background. So if we go into widget mode, if you double click and you go to the script, then it populates the default script. So when we go back here, we get the cell numbers. And if we change this one line here, you can see it's just taking that same number I, adding 64 to it and formatting it with this %A, which, see if you can guess what that's going to do. There you go. It just turns it into an ASCII character, or rather a Dec Roman character, because once you get past the end of the ASCII character set, this is the null character in ASCII, and this is the highest ASCII character, number 128. And then these are some new characters that Decker provides with all of its fonts to allow you to use just like characters from some other European languages. Okay, and then there's one other piece, which is data. And that is just something I added you could do things like, if you go back to the first card, like this tic-tac-toe thing. So my last video, if you haven't seen it, was about making a tic-tac-toe game in Decker, and we used individual canvases. And now this entire thing, which I believe I pasted earlier into another deck, has data associated with it. And what's happening is when you click on it, it's changing the data that's being stored in the widget. And so if we go to widget mode and click on this, you can see it just stores the data for the grid in an array of numbers that are either 0, 1, or 2 for X and O. And if we go to the script for this, you could see the encoded images for the X and O icons here. And so when I draw it, I'm just doing the same thing we normally do, but when it comes time to draw the square, I just paste in one of these images. I think I don't actually need the word copy here. So then there's also a pick handler. And so pick is like the click handler. It just draws like the view handler, but you get a reference to the internal canvas, and so you can draw on that canvas. The pick handler gives you the same as the click handler, but you get the grid coordinates and the number associated with that square you clicked on. For this tic-tac-toe thing, we just grab the data field, and then we take that index, we take whatever value is there, add 1 to it, and do exactly what we said earlier, take it modulo 3. So that means that the number 3 wraps around back to 0. Then, of course, we have to assign that back to the data. And that gives us this looping behavior when we just continue to click. Obviously not a full tic-tac-toe game, but now you can just paste this widget into any deck and you can do whatever you want to render the state of a tic-tac-toe game. And of course, if you click on the script, copy this string, you can say edit, paste image, and then you can edit it in Decker, make some changes, and then copy it as an image and paste it back as text into the thing. That's a neat thing you can do with embedding images as code in one of your widgets. Okay, so that's all the fields of this thing. Here's some more demos. The help also has a little bit of a demo. Like I said, I'm not going to go through this too much, but when you click on these, they do set the pattern on these little canvases up here. And so you have a little painting program that is really only a couple lines long. I encourage you to look at the code at this thing and just see how easy it was to wire all this together. But I think that's about it. So with that, I will say thank you for watching. And if you'd like to say thanks back, I'd really appreciate it if you would click the like button or maybe subscribe to this channel and watch another one of my videos. And that's it for today. See you next time.